Start recording. All right, thank you for joining us again, another session of Dynamo User Group. Thanks for coming. We have a great session today. My name is Cesar Escalante. I am the coordinator and I work for HOK, Design Technology Manager. Joining me here is Thomas Trinelli with Flux. Before we get started, want to go to some announcements. First, who is here for the first time? Okay, so if you want to get informed of our activities, forthcoming presentations, and our schedule, go to our website on the screen, sfdug.org, and sign up for the newsletter. And once a month, you're going to get the announcement with a speaker and stay in touch that way. You can also follow us on Twitter, and if you are open to present and show us your work, email us on the email on the screen. Those who are joining us online, we will be monitoring your questions in the questions panel, and from time to time, I will address the question to the speakers. Thanks for joining us as well. All right, I'm going to start the presentation with a very brief 10-minute Dynamo demonstration on a small package called Reanimation. And then I'm going to give the stage to Thomas Trinelli, who's going to talk about what's new on Flux. If you're interested in becoming a member for the group, send us an email. We welcome ideas. It's just going to take about 3 to 5 hours per month, and all we really talk about is what do you want to hear in these presentations, what speakers you may want us to reach out, and so we need help with marketing and reaching out and managing memberships, so feel free to reach out if you're interested. Another announcement, our first design script workshop is scheduled for June 22nd. That's going to be a Saturday from 9 to 4 at HOK San Francisco. It's already on the website, and the capacity is 20 people. So there's only about 4 spots remaining. If you want to sign up, $30 per person. It's a suggested donation, and the proceedings are to secure a better mic and get us paid membership on GoToMeeting. And so the instructors are going to be Armand, Halidou, myself, and Enrico. We're all part of the committee, so feel free to sign up if you're interested to learn about DesignScript. And you know, DesignScript is the Dynamo language, and it's text-based scripting within the Dynamo environment. In addition, I'm hosting a series of Dynamo Fundamentals series online. It's 5 Thursdays, and the first one already passed. The next one is tomorrow, and it's 1 hour from 10:30 to 11:30 actually. And it's about data formulas and list management. That's the website to sign up. And it's $49. It's not for me, it's for the Performance Network. And it's every Thursday until August the 3rd. So if you're interested, go ahead and sign up. It's intended for those who've never used or Dynamo and are interested in learning more about that. In addition, after my series of classes, Ian Siegel is going to teach during September a series of, again, 3 classes about specific Dynamo applications. Ian Siegel worked for Radley, and he has a very good class at lynda.com. And again, it's hosted by the Performance Network, $49 each. This Friday is the BIM 2017 conference in University of Southern California. It has a track that's highly focused on computational methods, and it's really a good bang for the buck, $55 in LA. And for those who may happen to be in Boston, there's a first Beyond AEC hackathon scheduled for the weekend of September 15 at Sasaki Associate. I believe it's going to be free, and it's a 24-hour intensive research project about computational design. Another announcement, speaking of conferences, August 5th and 6th, PGE is going to be hosting a live training by Mostafa Segedipour. He is the creator of Ladybug, and it's hands-on training from 8 to 4 p.m. Focus about climate data and daylighting workflows using Ladybug and Honeybee for Grasshopper. If you don't know, Mostafa is a really great developer of sustainable analysis tools based on Grasshopper, and it's great that we have him in the Bay Area. That doesn't happen that often, so take advantage. It's part of the pre-conferences of the Building Simulation Conference 2017, and if you're interested in that event, it's also great. It's been 15 years since we hold the IPSFA conference, so having it in town is great. It's around the corner, and it's not that expensive. I think it's $600 for a 4-day conference. I think I announced this last time. There's another conference, Advancing Computational Building Design, in August at Fisherman World. This is about $1,500. So, but several of our members, former members, are going to be presenting topics related to implementation of computational design at a firmware level. And lastly, save the date for our second-year anniversary. That's in August, Tuesday 29. This is a slight change, but typically we present the second or the third Wednesday of a month. In August, we're going to do something different because we have two great speakers, Kyle Martin, who is the coordinator of the Boston Dynamo user group, and Ryan Cameron, who is the Des Moines coordinator of the Dynamo user group in Des Moines. So each of them are going to have great presentations, so sign up for it. And then we have a very special appearance. I don't want to disclose it, but it's somebody very dear and close to the Dynamo community. So hopefully you can come here and find who that is. Thank you for our sponsors, and Ideate for the food, HOK for the hardware, and Gensler for the webcasts, and the AI for the venue. All right, so I have a 10-minute presentation about the Reanimation package, and I'm going to show you a very quick application of using some of the nodes there. And then I'm going to hand over to Thomas. All right. So in Dynamo, I was looking for a way to automatize the distribution of grids in curtain walls. And I've been searching for that magical node that allows us to do that. And through that, I came out through this. You can see I have a lot of packages installed. I came out through the Reanimation package by Travis Williams, who developed this little package which has a lot of interesting tools. I mean, one is the ones related to Revit has this ability, these two nodes that really caught my attention. One is the ability to move or readjust curtain grids. Another one is the ability to create curtain grids in curtain walls. And so parametrically, that has always been a challenge because one thing is to be able to select grids. Another is be able to delete them and recreate them without needing to run the script twice. And so after a couple of tries, I was able to come up with a very nice workflow. And so the potential uses of this is think about what it takes to create a pattern-based curtain wall. If you use the out-of-the-box functionality of Revit, all you see is regular distributions that are equally spaced, and you follow those three rules, I think, start, the beginning, end. But what if you want a distribution, let's say, 4 feet, 2 feet, 3 feet, and repeat that pattern over and over? That's not something that Revit does out of the box. And so let me show you the script here. And so this is a blank new project in Revit, and all I'm going to do is create a new wall using the out-of-the-box curtain wall. And if you're not familiar, this is the gigantic piece of empty curtain wall. This doesn't have any grids or predefined set of mullions. And so if I want to create a pattern distribution of grids, I have to do this one by one, right? The easy way of doing this is you create an elevation, and then you start placing grid by grid, and then using temporary dimensions, you start assigning them one by one, and then readjust their location. And so this process of putting grids one by one takes a lot of time. And then if you decide that the pattern needs to change, then I need to basically rebuild everything from scratch. So what a pain, right? So I look into Dynamo to see how I could expedite the process. So I'm going to launch it. And I made use of that little node from the Reanimation package. And so I call the script create a curtain grids by patterns. And I'm going to show the solution, and then I'm just going to walk into a couple of the nodes. So what this basically does, I need to select a curtain wall from the project. And then in this little code block, I define the pattern module that I need to do in both in the horizontal and the vertical. And that's all. This is in the units in Revit. So this could be 5 feet, 3 feet. Let's change it. Let's say in the horizontal, I want something that is 2 by 4 by 6. And in the vertical, I want something that is 1 and 5. And that's it. Those are the inputs from the user. And so running the definition will create that distribution. And so the color code is just a way to identify panels by the area and the size. And so if I'm interested to start exploring things like, well, what is the implication of that in a schedule, then I would open a panel schedule here. Go back to my 3D view and tile it. And see what these do. Say I want to explore different changes and have a total count of panels at the same time. And all I need to go back and revisit the formula. Say my pattern needs to be 4, 6, and 1. And the horizontal pattern changes like 2 and 6. Run the definition, and there you have it. Doing this manually, it's really intensive work. And so I have the schedule of all the curtain panels on the side, and I can see the count, and I made a figurative cost to start also looking at what it would take to build something like that. And the beauty of this also is that I have the ability also to change the justification. Say, right now, the start value is from the right. What if I want to do it to the left? If I want to do it from the bottom up? I just change this Boolean and run it again, and that changes where the start point is. And I could go even further and say I want it to be centered. I didn't develop that way. But the magic on all of it is right here in this module. This is a way to create curtain grids. And the other combination was to enable, I use this path-through node to wait for Dynamo to execute a command, a certain graph before it goes into the next one. And so this is from Clockworks. So that it is the application I have. I thought it was something I want to share. So if you have questions, again, Reanimation package, you can download it from the package manager. You can start building an application like this directly using Dynamo. Any questions? All right, so I'm going to hand over the presentation to Thomas Trinelli. I am going to...
I'll just change the mic on the other side because I need my voice.
Oh, yes. Make you the presenter. And you can wait.
Yeah, should load.
All right.
There you go. So I'll check for questions in the chat. Yeah, so for the people that are online, I'm also a presenter for this webinar. So if you have any questions at any point in time, just put it in the chat or in the question box, and I'll try to get to them at the end of the presentation. So we have a pretty full audience here on site. So for today, I'm going to start with a short 20-minute presentation of Flux as a whole, because, I mean, there was a lot of first attendees' hands, so I'm not sure if everyone's heard of Flux, so I'm going to start with a brief presentation of the company, and then more specifically, I'll dive into live demos of Flux and Dynamo. So I've prepared a couple of modules, and depending on the time that we have, I'll go through them one by one. So as an introduction, I just wanted to present myself. I'm Thomas. I'm an application engineer at Flux, which means I'm not specifically developing the platform or the products. I'm working with clients and users to implement the platform for their day-to-day. So whether it's hand-holding people that want to get started with a platform, or even creating custom code blocks or custom applications on the platform, we do a variety of things. And been here for about a year. So at that point in time, you kind of know the platform in and out. So if you have any questions, whether they're technical or not, feel free to shoot out, and I'll do my best to answer them. In terms of attending and the people that have been following us, I wanted to say a big thank you. So we're a startup, and we're a company that was started at Google X. We went out of Google in about 2012, but we've been completely independent since. And yeah, so I wanted to say thank you for everyone that's been using Flux, been using the platform. We're really trying hard to listen to all the feedback that we get from the different channels, whether it's, we have our own community websites, but we also are present on different social media channels. So if you want to talk to us, contact us, you can reach out on any of these channels. And we also have hello@flux.io email that you can feel free to email at any point in time if you want a presentation for your firm, if you just want general inquiry or anything. We also want to thank a lot of the companies that have been putting their trust in us since we're a very little company till what we are today. They've been putting a lot of trust also in our developer program. We'll show and later in the presentation that we have some companies that have started developing their own tools on the platform. So really want to say a big thank you to these. And the first thing I wanted to do before I get into our product is explain to you why Flux exists and why we built Flux in the first place. So we looked in the industry, we tried to make a pretty thorough analysis, and for us the three major problems that came out was the ones that are on the screen here. The first one is the data in the industry is very siloed, and same thing with the softwares. We've been talking about interoperability for a long time. We've done it with different, systems, different file formats, and so what we here today are trying to build is to build on existing softwares, and that provide a great solution for modeling, whether you're in early stage or in detailed stage. A lot of these softwares bring great solutions, but we want to make them talk to each other. So we want to improve them and make sure they are completely connected. And we're in the era of data. Everyone talks about data. I think there was this IBM report about 2 years ago that said that 90% of the world's data has been generated in the last 2 years. So this is also coming for the industry that we're in, whether it's architecture, construction, or engineering. And so by having a platform that's able to ingest that data and serve it in any way you want, I think it'll open a lot of doors. The second thing is there's too much rework. So I mentioned interoperability. When it comes to going to construction, a lot of what we do is then flattened as a PDF. We send screenshots, we send PDF, we send maybe spreadsheets, but I don't want to get into the reasons of that, but I think by having a seamless integration of the data and making sure the tools can talk to each other, we eliminate at least one of the major causes of rework in this industry. And finally, and that last point is what really drove our recent effort in productizing Flux into different apps, is the gap in mastering digital tools. So in the industry, there is different people with different skill sets, different ages. Sorry, I'm French, so different years of experience, I guess. It just sounds very odd. So what I was trying to say here is some of the new tools like Dynamo, for instance, might not be used by the whole firm. It might be used by 5%, maybe a small handful of people. But what's being used by everyone is a phone, an app. Everyone knows how to use Google Maps. Everyone knows, because these tools are simple and they provide a simple use case. And so this is what we've been doing with the apps that you can currently access on Flux, is make sure that each of these apps provide a single service that's simple and convenient. And so we'll talk about that. All right, so today what is Flux? Flux is three things. The first thing is, as I said, the powerful linking of building data. So we've created bridges for you to send your information from your design tools to the platform. So this is done through our plugins, whether you're using Revit, Dynamo, Grasshopper, Rhino, Excel, Google Sheets, you name it. We have about 9 plugins, I think, right now that are fully functional that you can use. We're constantly growing them to support more and more, data types. For instance, one of the recent things, so I'm supposed to talk about what's new. One of the very recent things that we've improved on the platform is the ability to export scene information. So if you create an object that has a specific color or a specific texture in Rhino, for instance, you send it to the platform. Now we're able to capture that. So there's a lot of subtle things that we're progressively improving in the plugins that hopefully, as we move forward, makes your life a lot easier in transferring the data from one software to another. On top of that, on top of the platform, once it's being fed with data, sits a lot of simple apps that will help you get your job done. So I think the two main ones that we're going to talk about are Site Extractor and Scheduler, and I'm sure if you've heard of Flux, you've probably heard of those two already. And finally, and this is for people that want to take it a step further and are coders or developers or hackers or whatever you want to call it, we are a development platform. So we offer services for developers. We have APIs in JavaScript and C#, which allow you to communicate directly with the platform. Everything we do is bidirectional, so it's not just about reading data, it's also about sending and receiving the information. So you can right now go connect, create an account, get the API, and build the tool for your own. All the plugins and all the apps that we have built that we're giving out to the public are built on the same APIs that we're giving you today. So anyone could build a plugin or an app to the same quality of what we've built our own. So powerful linking of building data. Currently, these are the software packages that we integrate with. So AutoCAD, Revit, Naviswork, Dynamo, and 3ds Max for Autodesk. And then we also have software vendors like Trimble, Rhino. We have a SketchUp integration and also spreadsheet tools like Google Sheets and Excel. And we started growing and looking at also, for instance, communication platforms like Slack. A lot of these software packages are new. Some of them are even coming. They're not even released. They're going to come through the summer and the rest of the year. So last year we presented in April, and I think at that point in time we had Grasshopper, Dynamo, Excel, and Revit. So since then we've grown quite a bit. We've released AutoCAD, Rhino, and 3ds Max. We've also stabilized a lot of our Google Sheets integration. So that probably opened a lot of new ways to collaborate and share data. So we've also integrated with third-party database. So as I said, Flux is a development platform. It's a data platform. So ultimately, our API cannot just integrate with other software's API, but it can integrate with any database. So if your firm owns a specific database of a city landscape or some weather data, anything, you could eventually also plug it to the platform. So what we've done with these databases specifically is provide a tool that's called Site Extractor that serves that data in a way that the other tools can understand. So I'll make a live demo on how we can use that with Dynamo and Revit. So example of simple apps. As I said, the parallel that we give is really the one on the phone. A lot of you recognize these apps, but what they all have in common is that they're built on the same OS, on the same operating system. And here at Flux, it's pretty much the same. This is how we envision ourselves. We're going to start and build a first handful set of apps that talk to each other, that are bidirectionally connected, and they are all able to talk to each other, and they capture data from the same building, from the same project. So in the long run, you can picture Flux as being this underlying canvas that gets informed by the building design from the very early stages of conceptual design to even construction and on-site. And so we are building an operating system for the building industry. So another big change that we've done this year is introducing the App Store. So right now, when you log into Flux and you create a new account, you get to this page. And we're still working really hard to make sure the onboarding experience is getting better. But this is what you see when you log in. And what happens is that you get free 4 pre-installed apps. By the way, we call it the App Store, but for now, whenever you get Flux, you get everything. So it's not like you have to pay for a single plugin. If you log into Flux, you have a free version of the platform, which limits you in terms of the number of projects and the amount of data, but you always get everything. And then when you get a paid version of Flux, you have almost unlimited amount of information that you can send to the platform and still also access all our apps. So the first 4 pre-installed apps that you see here are kind of core to the platform. They allow you to visualize information that you've sent to the platform. We also have our own computational design engine in the web called the Flow. So it's similar to Grasshopper and Dynamo. It's a flow-based programming, but it acts on any type of data. So it performs operations on BIM information, on tables, on numbers, on anything. And finally, we also have a project app which allows you to manage all your data, invite collaborators, pretty much like a Google Doc. You can, at any point in time, decide to invite collaborators to a project, give them a different level of access. So that's also built in the platform. And in terms of the apps, I'm going to demo today Site Extractor. So as I said, Site Extractor is connected to existing database. Some of them are open source. Some of them are proprietary, and we're using a service called Mapbox. All the information is public. You can go on our website and read about what type of data Mapbox serves. It serves OpenStreetMap, but not just OpenStreetMap. So it's a worldwide database which allows you to retrieve information about topographic data, the building contours, the roads, the park lines, water lines, anything worldwide. So with a click of a button, you get that into Flux, and then because we serve and we have an integration with all the other tools, then you can push it to Dynamo, Revit, SketchUp, and all the ones that I've mentioned before. Another one that we've built is this scheduling tool, which allows you to. Looking at an icon, it looked odd. And so the idea is, from here, what you're doing is you're sending Revit information or BIM data to the platform, and then you can create schedules directly in the web. So now you have a direct integration between Revit and Excel. It's live, it's bidirectional, so if you make edit to your schedules online, it edits the BIM tool, it edits Revit. So you can invite collaborators as well, so you could picture yourself. One of the main use cases that we've seen from our users is, for instance, communicating with subcontractors. Sometimes you don't want to send the whole model. You maybe just want to send the doors, or you just want to send the windows because they need to specify a specific detail about that door or that window. So you'll create a schedule, you'll invite them as a collaborator like you would do with a spreadsheet on Google Doc. They'll input the data here in the web, and that live updates your Revit model, and you have access and control on what goes back into the Revit model. And we also are growing these apps. So we have a section called Flux Labs where we surface apps that are currently under development. They're in beta, and we're looking for feedback on them. One of the one that I like is called Capacitor. So early company, pretty nerdy. If you've watched Back to the Future, that should ring a bell. And what this allows you to do is to go back in time for a single data. So whenever you send information to Flux, we capture the whole history. So if there's been an issue or an error or something that was introduced that you're not happy with, you can go back and retrieve a past version of that specific data point. So no information is really lost in the platform. You can always retrieve it back if there was an issue. And that's also part of the service that we offer. And for a free user, you have about 90 days of data history. So to get more, you need to get a paid subscription. And we also have a cool one called Terra, which allows you to push the model directly into Google Earth for visualization. So you can just push new geometry, and then on a click of a button, you see that on Google Earth. And finally, the last section I wanted to talk about is apps that other people have built. So we're an open platform, and we will support and we will help anyone that is interested in building their own apps. We have a team for that that provides support, we provide training for our SDK and API, and so feel free to reach out if you have an idea of something that you would want to build on the platform. And we also will open our App Store to third-party developers, so in the long run you'll be able to showcase your app in our App Store as well. And that is also depending on your own will. If you want to make the app a subscription service and you want people to pay for it, you can do it. If you want the app to be accessible by people in your firm only, we can also do that. So we can define the level of access that you want your app to be. So recently, the first partner that have been developing this app is Bureau Happold. So this is an engineering firm. I think they're mainly based in the UK, but they have an office in New York and Kansas. And they've built a site analysis tool directly on Flux. So what happened is that they had a Grasshopper script, a logic that one of their R&D team had developed, and they had a hard time sharing across the firm because not everyone was proficient in Grasshopper. And they also wanted to be able to send that data not just to Rhino, but maybe to Dynamo to start doing actual detailed design. So what we've helped them do is migrate that logic, that algorithm, that IP that they had built initially to the web, so that this logic, this algorithm could be accessed directly through URL. So now anyone in the firm can just go on the web, select a site, run the analysis, and send that as a baseline for their design, whether they design in SketchUp, Rhino, or even Dynamo. And we've published for them the app, so all the users at Bureau Happold are now able to access the app themselves. I think you can also access it through a public URL. So if you want to check it out, you can either reach out or go on their website. I think you can find the public URL for this app. All right, so just to finish up on this, what we're really, the keywords that we tried to keep in mind to define ourselves is Flux is really simple, it's open, and eventually it's powerful, because we are serving data throughout the whole life cycle, and we are eventually going to build this for the whole industry. So, without further ado, what I'd encourage you to do is to start bringing other people in your design. Other people, collaborate more. Disregard which tool. You don't have to focus. You don't have to worry about, okay, should I start by modeling in a tool or another one? Should I take a course on this one because the team has decided to go with this one? Just choose the one that you like. Choose the one that you're comfortable with, and then make sure the data can be sent to the rest of the team, to the rest of the collaborators. So, without further ado, so we are at Dynamo's user group, so I'm going to give a demo specifically on Dynamo. So I have a couple of examples I'm going to go through. Hopefully this should give you a good flavor of the type of things you can do with Flux. So I'm not an architect by training. I have a math major initially, and then I did some structural engineering. So these are just examples of what you could do, but I'm sure you'll get more creative and you'll have a lot better designs than my fake towers that I'm going to show. So feel free to just use them. And also, if you want these scripts or any of what I'm going to show today, also feel free to reach out, and I'm happy to share it by email. So the first one that I wanted to show is creating a floor plan and a building massing. And then looking at how to design complex parametric facade and create a native Revit topography using site Extractor, and finally how you can start mining Revit data with Flux. So a lot of people will probably ask me, but yeah, so I can already make a link between Dynamo and Excel if I work on my own computer. So why would I use Flux? Well, what's interesting with Flux is that it's cloud-based, so you don't need to send an email with an Excel spreadsheet. You just need to you need to connect that Excel spreadsheet with Flux. And same thing, you can do complex parametric facade in Dynamo now. Dynamo's grown to a stage where it's very robust, and you can build some very significant geometric models. But maybe the firm that you're going to work with is going to use Grasshopper, and you don't want to recreate the whole geometry from scratch in Dynamo because you're being tasked to design in Revit. So what you want to be doing is just taking the line work or whatever the output of the Grasshopper model is and start building from there. So that's the type of usefulness that Flux brings. That was for after. All right, so I've tested all these modules, and hopefully none of them will crash on me, but if it happens, this is the risk of doing a live demo, so bear with me. All right. So for this first one, I'm going to create a new blank project, and I'm going to open a Rhino model. So also Flux will capture all the geometry from one model to another. So for instance, if you're working in Rhino and your model has been set in millimeter, but your Revit model is in feet, you'll see something very small on your screen. So always be careful in making sure your units are consistent. So what I'm going to do is I'm going to open a predefined kind of massing model. So what I've done is I've created some, very simple, I guess, not really simple, but dummy, geometries and shapes that you can think of it as like, the massing of a tower. We're just very conceptual right now. We're looking at different options for towers. So I have this little kind of like rectangular one and then this more circular one. And what I want to be doing is taking that massing and start creating a basic floor plan in Revit. And so what we'll take is we'll take the surface either from Grasshopper or Rhino, and we'll slice it directly in Dynamo. So it will arrive as a native BREP in Dynamo directly through Flux. So let's do this. So I'm just going to open Grasshopper, and I'll show you that we can do it from both. I'm going to open the building massing. Wait. Okay, well that's starting good. I'm going to open the Dynamo on the other end. All right, and we're going to open. And another thing that I am doing in this workflow is also taking the levels from a different source. So assuming the levels have been, decided through some sort of a Excel spreadsheet, which will define the different elevations of the level, you also want to be able to integrate all these data sources to create the massing. So this, for instance, might be, the spreadsheet where all these levels are defined, and you have a required gross floor area, and eventually this is what you're going to go to is compute that gross floor area for your tower that you're working, and then have some sort of a check that says whether or not you're compliant with what was required. And so what I started doing was I created a connection with Flux, and I decided to send the different floor numbers, the different program types, as well as the elevations directly to Flux. So I send them through 3 different what we call data keys. And so the way we communicate in Flux is you create a connection from the tool directly to the platform. So if I create one live here, I'll just remove this one. What you do is you select the section of data, the cells that you want to connect, and then you create a new connection by clicking Add. And that opens a new window where you have to select a project. So what I'm doing here is, oh gosh, I'm not connected on the right. There's the risk of making demos. I have lots of different accounts. Let me just connect to the right one. By the way, that's a good way to show. So what I'm doing here is I'm logging to my accounts. Everything you do in Flux is password protected. So it's a secure way for us to make sure the data belongs to you. And we also don't have access to the data that you're sending. So sometimes we have users that come to us and they're like, hey, I have an issue. Can you look into my project? And we're not able to do that unless you give us access to your project data. So everything you send is yours, and it's protected. So what I'll do, as I said, is I'm going to select that elevation column. I'm going to create a connection, select the SFDUG massing project, and then within I'm going to select the data key where I'm sending the elevations. So I'm going to do this, and send it. And on the other side, in Dynamo, I'm going to open my massing to floor definition. Yeah. Going on. There you go. And so same thing with using the Dynamo Flux plugin, you can receive the information natively inside of Dynamo. So it's loading right now, but the first thing you do is you select a project, and then you define what we call a flow mode. So you can either work automatically, which means the data will sync automatically. Whenever someone makes a change, the data will be received automatically on Dynamo, or you can decide to gate the synchronizing speed, and if you click on once mode, you'll have to manually get the new version of the data. And in the background, what happens is that if I go to Flux and I access my platform, I can see that the data is being sent. So if I go to my SF massing project, I can inspect the data, and I can see, for instance, I have the circular massing and the massing for the rectangle building that's loaded, and it's a native BREP. So everything is native, and you can see there is also a scene schema that's being captured. So if we go back to Dynamo, I think it's loaded now. I can preview the massing to make sure that it was properly received, and you can see the information arrived in Dynamo, and if we inspect it, it's polysurface, so it really kept the native geometry of what I had initially defined in Rhino. And in here, I'm receiving the different floor names and different elevations that I was sending from Excel. And then so I'm sure you guys are all Dynamo users, so I'm going to go a little fast on here, but I'm constructing the level names, then I'm building the levels from here, and then what I'm doing here in the bottom is getting the massing and slicing that to get the different boundary lines that I need for generating the floors. So now that I get all my boundary lines, I can directly create the native floors in Revit. And so if I minimize that window and I look in the 3D view, I have a rough massing of my building being generated in Revit. And so if I go back to Rhino, and instead of sending the rectangular profile, I send the circular profile. So I'll go to the connection manager for the Flux plugin. I'll just sync and say, please send the circular profile this time. And in Rhino, what I'll do is I'll select the circular profile instead of the rectangular one. And this will change the surface here, and everything will regenerate. So what's interesting is you can let the conceptual work happen in Rhino, and then you can receive that information directly in Dynamo and start doing all of the massing in Revit to start your detailed design work. And so this is really the tip of the iceberg. I'm sending a poly surface. But you can start sending lines if you're doing line work, or anything you're doing in Rhino could be sent into Dynamo. And same thing, now what I'm going to do is I'm going to receive the gross floor area that I was computing in Dynamo. I'm going to send it into my Excel spreadsheet, and you can see all the elements have been populated, and I have this little compliance check that tells me whether or not that specific floor is compliant with what was required. If I make a modification and I suddenly decide that I want to change the height of this office space, and I'm going to put 6 instead of 4 for these two, I'm simply going to sync the data of the floor elevation, and it will update the Revit model. So you get really completely, you see the spaces that are being increased. You get a completely bidirectional workflow, and your tools are really working in sync. So you could picture someone doing all the spreadsheet work in Excel, someone else doing the conceptual design in Rhino, and then someone in charge doing the detailed design in Revit. So I guess the next one that I want to show, so I'm going to move to the next module, is using the site extractor. I like it because it's fairly visual. It doesn't include Rhino Grasshopper. So I'm going to close this one. I'm going to open a new definition.
So the Excel sheet wasn't generated by Flux. It was created and placed into Flux.
Yeah, exactly. The Excel spreadsheet was generated externally. Someone just sent it to me. It was, you can think of it as a program, and then I sent the data to Flux using the plugin. Yes.
Is there a limit in the amount of data you can send via Flux?
Yeah, so it's not limited per data key. If you send 2 gigs in one data key, it'll take quite a lot to just load. But what happens is we limit you in terms of the space that you host in the platform as a whole. So if you create 100 data key, you might reach a limit, and what happens is we limit it at 2 gigs. So right now we're limiting it 2 projects for free users and 2 gigs of data throughout the 2 projects. You can also remove the data and repopulate it, and then if you go through the paid subscription, we currently don't have a cap for the number of projects and the amount of data you can store in the platform. Yes, go ahead.
Does it work without the Dynamo tool, just from?
Yes, so you could set up workflows to work directly from Revit. So we have a Revit integration. Actually, that's one of the modules that I want to show. So some of what we do, you don't really need to go through Dynamo. And for the sake of here, I'm leveraging the ability for Dynamo to do all these computational logic to do some of the workflows. But we have the ability to generate direct Revit elements in the web and receive them through the plugin. So you could picture, offloading that logic to the web, running it into the background, and receiving it directly into Revit. So you wouldn't necessarily have to open Dynamo on your screen.
Sorry, one more. When you
Yes.
say it's bidirectional, if someone changes the elevation in Revit, does it get back to Excel too?
Yeah, so if I were to, so I know this, I mean not anymore, but if I were to change, for instance, this floor plan and the logic, still hold with Dynamo of computing these gross area, then yes, the data that I was modifying in Revit would be sent to Revit, to Excel as well. All right, so let's go to Flux. Let's open the Site Extractor app. So go back to all the apps, and I'm going to open Site Extractor, which is right here. I'm going to launch it. The first thing you need to do is authenticate. So what we do with all our users is you have to authorize the app to be connected to your account. So that's kind of similar to when you install an app on your phone. So you're going to click here. You're going to allow the app to be connected. And the thing you do is you select a site. So if we select this building, for instance, in San Francisco, I'll be redirected to that area, and I have this little selection box that I can move around to select a site. I can change the size of the box. I can change the location of my site. And then what I have to do is to select the different data types that I'm interested in. So if you want the building footprint or the building heights with the model and the extrusions, the topography, and so on, you can also define the intervals of the contour line. So let's say 10 meters, for instance, and I get some water just to see some more interesting topography. And then the next thing you do is you have to select a project. So for this specific use case, I'm going to use the site context project, and I'm going to send the data to Flux. So what Flux is doing right now is scraping the information. It's taking all the data from OpenStreetMap, USGS database as well, and it's sending it to the platform. And so maybe the first thing I want to do before sending it to Dynamo is visualize that I've extracted the right site. So I'm going to launch that, and I have all my data types that have been pre-populated. And if I double-click on one of them, I can visualize it directly. Oops, loaded a little bit too much. I can visualize it directly in the web. I think got a little bit excited with the side of that window. So I'm going to close that, reopen it. And you can also overlay them together, so I can add the contour lines directly in here. Doesn't look like I have very interesting topography, but I can add the building footprints as well. So I have all the building footprints of the city of San Francisco in here, and I can add also the massings. So depending on whether or not the OpenStreetMap gives us the accurate height of the building, we will generate the whole building massing. You can also get the park and road line, lines. So from here, you're probably wondering, yeah, that's nice, that's cute, I can see it, but I want to be able to model with it. So what we'll do is we'll create a native topography from that information. So we're going to go to Dynamo once more, and I'm going to open another definition. And it's very, very, very simple. It has 5 blocks. The 3 blocks on the left are the Flux blocks. So as I said, the first one is allowing you to select a project. So you're selecting your Revit topography project. I'm going to change that in a minute, just because I was working with the SFDUG massing project. And then you select the data type, so the data key. So this will be the topography. And what we're going to use is the mesh vertex block to get all the points from the mesh. So yeah, generating the topography can be, depending on the size of your topography, can be a little tricky. Gosh, what's going on my screen? That's what I was worried about. Revit not behaving.
The question, are
yes.
the buildings then part of the topography category?
No, so what happened is all the data was sent separately in different keys. So the buildings are just a key with the buildings, and the topography is another key with the topography itself. And so you choose then to send whichever data you want. So there you go. Okay, that was pretty complex. So I guess let me just do that step by step with you, just to clarify that a little. So I'm going to log out. I'm going to log back in. authorize the app to be connected to my account, like I explained. And then I'm going to select the project, the SF massing. And this is where you're going to select the topography versus the building height. So I'm going to select the, no, not the massing, sorry. The one side context. And I'm going to select the topography. And this will recover the topography that I've just selected, create the points and create the topography in Revit. So what's interesting is if I change the site from Site Extractor, then all this updates real time. And so you can see the topography being generated in the background. There you go. If I go to Revit and I rescale that view, I have the topography. Let me just hide all this, because otherwise you don't really see much. But this is native topography being generated directly in Revit. So this is a native object and you can start modeling with it. And if I go back to the Site Extractor app, and let's take Twin Peaks this time. Twin Peaks might have some more interesting topography. So if I take like this section here and I update with the site context, everything will be updated in Revit accordingly. There you go. And so now I have the topography of Twin Peaks in my Revit model. So you could also extend that and start using the model lines to generate the building contours and start modeling around that. And so you have your whole site context. So it's pretty busy right now because I also I think when I extracted, I selected a pretty large a contour interval, but I could instead of putting 10 meters, if I put 50 meters, the accuracy of that topography would be different. So that gives you a pretty, very easy way to get actual Revit topography in your model to start, modeling with accurate topographic information in Revit. The other example with the site context was to create the model lines. So if I open the model lines example, what I'm going to do here is a similar process where I'm going to go to my project, and instead of selecting the topography this time, I might want to be able to select the building contours. So I'm going to get the building footprint, and then I'm creating a NURBS curve to generate all the model lines for Revit. And so what happens here is I have the model lines being generated in Dynamo, and the next step is to create actual model curve in Revit. So all these are following the topography, so they're actually 3D lines. But if you wanted everything to be flattened, you could do that as well. And so here now I have actual, model lines that for my building contour, so I can start modeling in Revit with these model lines. All right, and let's go to the third one. So hopefully you're still bearing with me. There's another use case that I wanted to show, which was doing some facade modeling. So I've been helping a client lately doing a lot of that because the subs that they were working with were using extensively Rhino and Grasshopper to do all the work in the factory, because the geometry that they were able to generate in Rhino was a little bit more accurate, but they also wanted to have the detailed plans of that particular roof structure printed in Revit. And so what we were working on is the ability to get all that structure that was constantly moving. It was being updated almost like twice a week, and have that structure that was designed in Rhino through a Rhino shape being updated in Dynamo and then in Revit. So I'm going to switch to that other project called Facade. So for the purpose of this one, I had already created some sort of a simple structure using Grasshopper. So I'm going to open my Grasshopper right here. rid of that. So what this is a very simple model where I'm generating some sort of a surface with different circles. I can move them around, and then I'm using a block from Lunchbox that allows me to do a diagrid, kind of some sort of panelization. And what I want to be doing is from here create actual glass panels in Revit and actual beams in Revit rather than just generic, direct shapes or generic elements. So what I'm going to do is instead of sending everything, instead of sending the actual geometry, I'm going to send what's needed for Dynamo to generate these items. And so what I'm doing is I'm extracting the points. And so for all these panels to be defined, I'm extracting the points here in Grasshopper. I'm sending those points to Flux, and then on the other end, in Dynamo, I'm going to reopen Dynamo. Gosh, my Manage tab just went away. So I'm going to open Dynamo. And this time I'm going to open the third definition to create the facade. So I'm going to use this. And what I'm doing is I'm on one end receiving the points, and on the other end I'm receiving the lines. So if I run this, you can see that I'm receiving the panel points and the panel lines. And if I inspect the geometry in Dynamo, I have this geometry being received over there. And I can also preview the points. There you go. And what I'm going to do is I'm going to use those to generate the model in Revit. So as you're aware, you'll have to have the families opened in Revit. So I just have to open the right Revit model, because, oops, no, desktop, SFDUG, facade. So I'm going to open this one. I already made a test earlier today, so I already have my little, you can have a preview of the result. But I'm going to cancel that. I'm going to reopen Dynamo. There you go. All right, so if I start from here, I redo what I just did, just to show you the step-by-step. Run those, so my elements are being generated, so I have a preview in Revit. The first thing I'm going to do is generate the glass panels, so I'm hooking up the points with a Create Adaptive Component node, and I'm selecting this Adaptive Glass Panel 9 points family that I created for the sake of that presentation. And then as I run it, the glass panels are generated here, and I could, modify the geometry in Grasshopper, and this will be updated live. So if I do a change in the geometry that I wanted to define, so I'm going to go here and modify this. I go back to Dynamo, and what happens is I see that this connection is turned yellow, telling me that the data that is in the platform is not in sync with the data in Dynamo. And so, as I said, if I had my flow control, or it's running right now in constantly mode, if I had this running as an automatic mode, the update would have happened automatically. So right now I'm setting this as a manual update. And so as I click run, it will regenerate all these panels and the data updates. So that's a very easy way. There's no file updates. There's no reason for the data to be lost somewhere. It's all living in the platform, and the subs that we're working, Grasshopper and Rhino, could just, as soon as they're done, sync with the data, and then in your office you can recover that information. And then what we're going to do is we're going to create the beams. So if I connect that, it will generate all the native beams. So I have here, I zoom, and I can see that these are native Revit beams. There you go. And so that's using the structural framing beam by curve block in Dynamo. And again, if I were to make a modification, maybe this time I'm going to modify the diagrid. modify this so I have my grid system that's moving a little. I go back to Dynamo, run it again. I have all the data that's going to update. It's flowing through the platform. There you go. So now I have my other model. All right. So the last thing I wanted to show, am I still good on time or? Okay. So is there any question on this particular workflow? I know we're very going through detail examples, but yeah, I wanted to show some educative content and how to use Flux with Dynamo. And so the last one I wanted to show is how you can actually mine kind of Revit models with Flux. So I'm going to open a simple Revit model. So this is the one that everyone has access to. It's the simple Autodesk model, this little house right here. And so what I've done is I've sent part of the data to Flux using our Flux product for Revit. So we have a connection here with Revit. If I send that to Flux and I can inspect it directly in the platform, I can see that all the geometry has been sent along with the metadata. But what happens is we are constantly growing this plugin, and not every single category of object is being supported by the plugin yet. So if I navigate through that little house here, I can see the foundations, for instance, are absent, just because the Revit plugin doesn't have the ability to collect all the type of families. So I'm going to use Dynamo to extract that information and send it. And I'm extracting that geometry natively. So for instance, if you were doing some energy analysis, you can extract all the geometry from Revit, push it to Grasshopper, run your Ladybug, Honeybee, and that can be done live with Flux. So as the Revit model updates, you send updated data to Grasshopper. So what I'm going to do is I'm going to open another Grasshopper, another Dynamo definition. If this one wants to close, no, it doesn't want to close. There you go. So what's happening here is I'm extracting the objects from Revit. So I'm selecting a specific family category, like the structural foundation, and then I'm on one end, getting the parameter, for instance, the volume parameter, or I'm extracting the full list of parameters here, or also extracting the geometry. And I'm sending all that metadata and the geometry as well in Flux. And so what's happening is all this geometry is being generated as a list of solids, and we'll go ahead and inspect that in Flux. So you can see I have these three Dynamo objects, Dynamo keys that have been created. And if I double click on them, I can inspect them. So this is the list of parameters that comes as a table. So all the foundation objects and their parameters are being sent. This is the list of volumes for all the foundation objects. And then I have the geometry as well being sent in Flux like this. And I could, if I wanted to, just visualize that with what I've already sent. There you go. And then I have both being loaded directly online here. I could generate that as a public data key, and I could also send it to anyone. So if I want to show update, I can turn that into a link. Control C that specific URL, and then if I open it on an incognito window or I put it into an email, anyone can access that data in the web. So it's going to load, and I have the geometry that I just generated here, can be accessed anywhere. So if you're trying to show progress to your project manager or something, you don't need to send the whole Revit model. Just publish it to Flux, share that link, and there you go. You have the model in the web. What's interesting is you can think of this as being first step to performing, for instance, thermal analysis or energy analysis. I was showing an example with structural foundations, but if I were to open the architectural model of that particular building, I could send all the rooms, for instance, and extract the the thermal properties of that room, send that to Grasshopper and run, for instance, an analysis with Honeybee and Ladybug. And so I'm really mining the data that was in Revit and I'm sending it to Grasshopper. So that's the 4 use cases that I've had prepared for today. I'm open to receiving questions. So if you guys have any questions, feel free to ask. And I'm happy to show more of the platform as well. All right, let's see. Do we have questions online as well? Yeah.
Do you have for your first example where you link the Excel sheet?
Mm-hmm.
So what I want to ask you, if you make a copy of that Excel sheet, you have to relink it again?
No, so if you, so whenever you save your Excel spreadsheet with the connections, that's also already embedded in the Excel spreadsheet. So if you reopen it somewhere else, if someone copy pastes that Excel spreadsheet, the connection with the platform will already be made. And so then that's a risk that you're taking if you're not, if you're setting your connections as in a constant mode, it will always load with the platform. And so if these connections are set in once mode, what happens is you'll receive a notification within the spreadsheet that tells you that the data is updated, and it's going to prompt you to receive the newest data. Yeah. Yeah.
Can you link with multiple Excel files?
Yeah. One example. So I can't really show the data, but one thing that I was helping a company do the other day was they had a list of 11 Revit models for a hospital. And their operation guys on site were only working out of one single Excel spreadsheet. So that's kind of like the other way around. It's several Revit models with one spreadsheet rather than several spreadsheets with one Revit model. But what we're doing is we're sending all the rooms to Flux. We were getting the information to feed it to the Excel spreadsheet. And then the operations guy were updating the spreadsheet. Like they were saying, okay, status of the room cleaned or status of the room whatever. And they're sending it back to the platform, and then it would redistribute to the 11 different Revit models. And they could update the attributes of the Revit model directly. So that's kind of the other way around. But you could picture these 3 columns that I initially showed being in 3 different spreadsheets. That doesn't really matter. Actually, if you go to, that's also an interesting aspect of the platform. And in the long run, we're hoping to make use of that. But if I go back to my initial model, about the massing where I was linking with Excel. You can see here if I expand that view a little that I have this little activity and I can click on it and I see the activity of that specific data key. So we are able to track who made the change, when it was made, and from which file it came. And so you, in the long run, can also have a full audit of the building data as you're working in Flux. I'm sorry, I guess it updates. There's a little lag between my screen, but it will show up, I guess. Yeah, there you go. So let me just redo that. But if you go to this specific screen with your different keys and you expand with this little arrow here, you can inspect the activity level of that specific key. If you click on View All, it gives you the history. So if we were several collaborators working on this specific project, maybe my colleague Joel, it would have said here, Thomas updated this at this time and Joel updated this at this time. And to do that, I would have had to invite him as a collaborator. So from here, I would have had to add a collaborator and then say, Joel, please come and feed your data to the platform. And that way he would be able to also edit, and I can give him a different level of access. If I just want him to be able to receive and view the data, I'll give him as a viewer only access. Do you guys have any other questions? Yeah, sorry.
Doesn't matter which version of Revit or which version of Rhino or which version of Excel?
No, it doesn't matter. So as long as the version is supported by our plugin, Flux will work regardless. So right now for Revit, I think we work from 2014 to 17, and we're releasing 2018 shortly. It should be in a couple of weeks. We're currently evaluating. We've already built the plugin for 2018. We're just going through QA right now to make sure that there is no issue. And actually, that's an interesting aspect because, I mean, you probably face that many times as you're using Revit. If someone sends you the most updated version of Revit, you won't be able to open it in an older version of Revit. And we've seen people use Flux just to get newer objects from a newer version to the older version of Revit. Because you can go through Flux, you'll send data to Flux and receive it into the Revit, the older version of Revit. Yeah, I know there's some Autodesk folks in the audience. But yeah.
One more.
Yeah, go ahead.
If you go back to the PowerPoint,
Yes.
slides where you were showing which software you work with.
Yes.
I wish your vendor was there. No?
Yeah, so that's a good point. Inventor is more on the mechanical engineering world or industry. I think, yeah, we haven't touched more on the software yet. We're looking at other options for future integrations, but yeah, it's always a matter of what we prioritize. But, yeah.
Seeing more architects are using Inventor now for a variety of reasons. So.
Yeah, well, we have a wait list of, so we collect everyone that wants a specific plugin. Feel free to send your requests, and we keep track of, and we try to prioritize which one. Gosh, this is really slow. Try to prioritize which plugin we're going to develop next through that wish list. So I'll keep that in mind. Yes.
Where's the map coming from you?
So for Site Extractor specifically, we're using a service called Mapbox, which is a conglomerate of different data sources. So if you go to their website, Mapbox, it's a cartographic company which serves the data through an API. And the advantage here for us is that we don't have to manually make sure that we feed the latest OpenStreetMap database to the system. Mapbox takes care of that for us. So some of it is OpenStreetMap, some of it is USGS survey data, so it's satellite imagery for the topographic information. And I know that Mapbox also collects proprietary database of cities, like major cities like Singapore or London, and they put it into their API. So it's not just OpenStreetMap. It is a consolidation of several data sources. And we're also currently working in growing this Site Extractor tool. I know that shapefiles is largely used in the industry for communicating GIS data. So I'm not promising anything, but we are looking into growing Site Extractor as well.
So random height buildings.
Yes.
And the height information there.
Mm-hmm.
They match to Google 3D building.
Yeah. So, oops, sorry. I'm trying to load. So the height building, the height information is computed in the following way. If we get the accurate height from OpenStreetMap, we will generate the actual massing as the building mass. If we are not, let me see, let me just load. So like the Site Extractor. So you probably saw here that it says building models, and then there's this tick that says randomly generated building height. So what happens is that if someone is selecting a site where the height of the building is not being entered by a user or anything, we give you the option to generate random massings. And so the way they're being computed is that we're taking the surrounding buildings that have accurate height, and then we have a normal distribution for generating these random buildings. I guess the advantage of that is that if you're using a tool like SketchUp or Rhino to do your city landscape, it generates native objects that you can then manipulate, and then you can modify to match the accurate height. But that's just because we are only as good as the data that's being given to us. And so if some architectural firm then decides to go and input the accurate height of every single building in Chicago, then tomorrow we'll have the whole of Chicago City also modeled. But yeah, so OpenStreetMap is an open source database, so anyone could go and feed in the right information. Yeah.
Can you only represent it as a line?
The road, yeah, so that's another question. OpenStreetMap will give us the road as a line, but that's a good question. So if you are a fairly advanced computational designer, you've probably probably looked at what type of metadata we embed with Site Extractor. And so if I open the roads right here, I can go in the raw data and I can see that there is some metadata assigned to it. So every single line has metadata, so it has some sort of a size attribute. So what OpenStreetMap does is that it categorizes roads in different sizes. It's not necessarily the accurate size of the road, but for the purpose of generating some sort of a more realistic view, you could use this size and generate, like a size 1 would be like a 10-meter width road and so on. So you can recover that metadata and generate the massing in Rhino. So we're not generating the actual width of the road because it's not being given to us through this platform, but there is the attribute of the size and the type of road that we're looking at. So you can use these metadata to generate your city massings. Yes?
There's size restrictions for the site extractor tool?
Yes, there is a size restrictions. On top of my head, I think it's 4 kilometers square, which for a city building is fairly, I think, okay. It's not the best tool for if you're doing, a large infrastructure projects, like you're doing road work or very large bridges, might not be the best, but for any building project, I think 4 kilometers square is, unless someone has a better option, that's the option that we've set. Yeah. You had a question? Yeah.
Is it possible to connect, let's say either to push the information inside Flux, the data inside Flux, out to an external like SQL database, or to connect, I guess the real interest is getting something like a business intelligence software to tie into that?
Yeah, so Power BI is something that comes back a lot. I know that it's starting to get some traction in the industry. What we'll do is, as the platform, will serve you the data both through the JavaScript API and through the C# API. So everything we capture and everything we have on the platform is JSON, as the data type that we're using is JSON data. So I know Power BI works with Excel, so you could always go through Excel to feed Power BI. But yeah, tomorrow if you wanted to create an integration with an SQL software or direct integration with Power BI, you could do it as well. But we don't offer that off the shelf. I'm not saying it can't be done. It's just not something. Yeah, it's not something that's here on the shelf. Yeah.
So I see an expansion of the apps available from a year ago.
Yes.
So is your plan to continue adding and enabling third-party developers to put those on the app stores and version them as subscriptions?
Yeah, so that's a good question. I think that's a topic that we were talking about with Cesar before you guys came. So a year ago when we did this presentation, we had 4 products out. We had, as I said, Revit, Grasshopper, Dynamo, and Excel. Now we have 9 plugins and we have growing number of web apps. So the question is like, are we going to be a app company? Are we going to build 100 apps? This is not what, our objective. We are going to build a handful of apps that hopefully you guys will find a lot of value from. But what we want to build ultimately is the platform underneath. So we want to empower future developers to come and build their own apps. So the JavaScript and the C# API is just the beginning. We have other software languages in-house that we have an API for. That we don't surface to the public, but to name some, we have a Python and a Ruby API. They're not available to the public because they're not ready yet. But in the long run, we are hoping to provide more and more services for developer and make it easy and easier and easier. We actually are very keen on open sourcing some of our technology. So if some of you have development efforts or innovation and R&D efforts in your companies, the viewport that we have on the web that I've been showing you is completely open source. So anyone could go and take it and embed it into a website. We also have public GitHub repos where we show example plugins, example apps. There's a prototype site extractor app that's completely open source. So anyone could take that, replicate it to start building something else. And we are currently working also in making kind of bootstraps. So if you guys are familiar with that term, it's kind of like a template for building an app. So you can just, you'll have template with connecting to the Flux platform. So it's almost like, think of it as Lego blocks. We're going to give you all the Lego blocks to build an app and make it as easy as possible. So we're turning basically the development of building a Revit plugin from something that might take 8 months to a year in something that takes 2 months, maybe 1. Yes?
So I see 3D Studio Max in beta mode. What type of geometry you use from that software? Like I see nerves probably.
Mm-hmm. So actually, let's go directly to, so all this information, by the way, is available online as well. So when you go on the App Store, for specific plugins, each plugin have a detail page. And so for 3ds Max specifically, the data types that are supported are point, line, polyline, mesh, curve, polycurve, and B-reps. So all these are the supported data types for 3ds Max. I know it's lacking some texture abilities. So we are trying to work to make sure we can support more texture, specifically three-dimensional UVW texture with Rhino, because right now I think we only do UV. Yeah, if that's...
And this is like supports, I see it's released May 3rd, this plugin, so it's like probably supports the 2018.
This supports 2017. It doesn't support 2018 yet. But I'll make sure to add it to the wish list. Any other questions? All right, let me just check that we, yeah, go ahead.
One quick one. So kind of, can you talk about your roadmap at all? So like what's up for the next year? You know, where are you targeting?
Yeah, so that's an interesting question. Another thing that we're discussing with Cesar. So Flux is a startup. We are limited in resources and people and funding. So we are trying to prioritize in something that makes the most sense for us, economically speaking. So we are working on releasing a product this summer that's going to target another section of the platform that we haven't leveraged so far. I'm not able to disclose what it is, but you'll know about it in about a month and a half. Our immediate roadmap is to solidify as much as possible the current ones that we have, such as Scheduler, something as simple as making schedules in the web. We want to make these tools really like the click of a button. Like you just send the data to Flux, you say you have a template for a schedule, it's already generated, anyone can access it. And we are also working with a lot of third-party developers. So in the near future, we're hoping to start publishing third-party apps on our App Store. So we have a network of partners that we're working with to develop future apps. So I guess to summarize, the roadmap is this new product that we're going to release, working with third-party developers to develop apps that they're already finding value for, that will be hosted on the platform, and growing and supporting the platform more and more. So we're using these early partners that put their trust in us, and we're working with them to grow the platform to fit their needs so that in the future there's less and less friction for them to come and develop with the platform. All right, let me just check that no one has asked questions online. I don't want to miss out on these. All right, I think we're all good. Let me check the chat. No, we're good. All right, I will hang out a little bit more if you guys have more questions. If you guys want to talk to me, I'm happy to hand out business cards as well. And Joel, my colleague, is here on the right, so feel free to talk to him as well. All right, thank you guys.
Thank you. So this is going to be posted after the weekend, and if you have a data set, we can also put it on the website.
Okay, all right. I'll make sure to zip these files so that you can put it on the Dynamo Demo website.
Thanks, everybody. See you August.
Yeah.